Alright guys, so we have covered how to test solutions, solutions being values for variables that make equations true. Today we're going to go over how to actually find solutions to equations on our own. So, some foundations we have to go over. So the first foundation we have to go over is anything plus 0 equals itself. So, a couple examples of that. 0 plus 5, 0 plus 10, and 0 plus x. Well, 0 plus 5 is 5. 0 plus 10 is 10. 0 plus x is x. So you'll notice 0 plus anything is itself. Important to remember that going forward today. Second foundation thing we have to remember, anything multiplied or divided by 1 equals itself. So we have 1 times 5, 1 times 10, 1 times x. You might already know what those are. 1 times 5 is 5, 1 times 10 is 10, and 1 times x is x. All right, so we got the foundations out of the way. Here are some rules. We're going to go over the rules and we're going to do some examples. So, rules for finding solutions. Remember, the whole goal is to get x equals a number. Now, x could be other letters also, depends on what letter the equation is using. But in general, we're trying to get that letter to equal a number. Another phrase is get x alone. So what we do is we keep the variable in the same spot, but we're going to move everything else away from it. We're going to move things by doing the opposite. I'll even say doing the opposite operation. We'll see what that looks like in the examples coming up. One of the most important rules, all the rules are important, but this one is especially important. Whatever is done to one side must be done exactly the same to the other side. When I say sides, I'm talking about sides of the equal sign. We'll see that in an example. Speaking of example, here is example 1. So, example 1 says they want us to solve for t. Whenever you see solve for something, that means get t equals some number, just like we talked about in the rules. So what's the equation they want us to do to solve for t? So we have t minus 97 equals negative 38. First thing I like to do is draw a vertical line under the equal sign. Remember, this line is going to represent the equal sign. So we can put a few more equals on it. I wouldn't do it yet though. Don't do it yet on your paper. Just trying to get you guys to remember this line represents the equal sign. So t is our variable. We want to get t by itself. What do we have to move? Well, we have a negative 97 here. So t minus 97 or t plus negative 97. We remember how we talked about turning a subtraction into adding a negative. I'll write that out just so it makes sense. T. And really, we could rewrite this as plus negative 97. It means the same thing. Equals negative 38. So, okay, so we just have to add the opposite. So we're going to add the opposite of negative 97. Well, the opposite of negative 97 is positive 97. So the reason I'm doing that is because negative 97 plus 97 equals 0. We didn't do anything to t, so t drops down, so we have t plus 0. Well, anything plus 0 is just itself, so this is really just t equals. Now the other rule though, is that whatever I did to one side of the equal sign, I have to do the same thing to the other. So I added positive 97 to this side. I have to do the same exact thing to the other. I have to add positive 97 to this side. So over here, now we're going to do negative 38 plus 97. That's going to give me something different than 0. Let's check it. That's going to give me positive 59. And there we have it. So t equals positive 59. Here's how we can check it. It's always helpful to do a check. So we know that our original equation was t minus 97 equals negative 38. That's a little sloppy there. Sorry about that. I can take what we found the solution to be, which is 59, and I can substitute that in for my variable. And if you type that in, 59 minus 97 into your calculator, you will find that that equals negative 38. And just type that on into your calculator, and we see how this is true. So we'll say true t equals 59 is a solution. There we go. All right, let's look at another example. So solve for d, we want to get d equals, and now we have 3d equals 3. So for this one, again, I'm going to draw my line under the equal sign. Now this one, again, the rule stays the same, is that I'm going to get d alone, so I have to move this 3 over here. And I'm going to move that by doing the opposite operation. So right now, this means 3 times d. That's what it means when you have a number and a letter right next to each other. The opposite of times, or the opposite of multiplication, is division. So we have divide by 3 and divide by 3. Now let me break down what really is going on here. So 3d over 3. Another way I could actually write that is, so I have 3 times d. Now I'm dividing by 3. So I can put a 1 under d, because I can make anything a fraction by putting 1 under it. So really just remember though, when I multiply fractions, I do the top times the top, the bottom times the bottom. So don't write this down, but this right here is still equal to 3d over 3. 3 times d is 3d. 3 times 1 is 3. So that is all fine. I can still have that. That's just another way of writing it. Now, 3 divided by 3 is 1. D divided by 1 is D. 1 times anything is itself, so really we're left with just D. Now over here, 3 divided by 3 equals 1, so D equals 1. Again, you can check 3D equals 3. Substitute my solution that I found, which is 1. 3 times 1 is 3. 3 equals 3, so this is true. So D equals 1 is a solution. There we have it. So one more example, because this one will pop up and fractions confuse people sometimes, so we might as well go over it. So right here, solve for p. We have 2 equals p over 3. Let's go ahead. So I want to get p alone. I have to move this 3 then. Well, what's the opposite of division? Because this fraction bar represents division. The opposite of division is multiplication. So I'm going to multiply each side by 3. So, again, let me break this down to show you what happens. So we have p over 3 times 3 . I can make anything a fraction by putting it over 1. I can actually rewrite this as 3 over 3 times p over 1, because remember, when we're multiplying fractions, you do the top times the top, bottom times the bottom. When I do multiplication, the order doesn't matter. I can switch them around. Over here, I want to keep track of what's going on this side. So 3 times 2 is 6. Six will drop down with me. Extend my line down. 6 equals, let's see, 3 divided by 3 is 1. P divided by 1 is P. 1 times P equals P. So 6 equals P. Little check over here. We have 2 equals P divided by 3 was the original equation. 2 equals, we found out 6 was P. 2 equals, and let's see, 6 divided by 3 is 2. So we are good. 6 equals P, or P equals 6 is a solution.